All right, everybody, a little follow-up. I didn't film this before I put it all back together because, you know, I got to make a living too, and time's money. I'll teach you that in class too. But you see, everything's working. But what I did is in this box, and that's just hanging there because that's just an old fixture that was laying around that I'm using to test this to make sure I'm good, along with my voltmeter before I put that up. But the customer may be changing the fixture. That one's a piece of junk, and I hope he will, but that's up to him. And the fan, as you see, is running. I had to take the fan down, and then this box, of course, is already open, and I had to come in here, if you go back to the video that I showed you earlier, and I had to change over the wiring here and here so that we were looping the ungrounded hot conductors from each box to here. And now that's what we've done. And so when I turn off that switch, there she goes, right? On and off. When I turn off the other switch, there she goes. This one's not affected, okay? So we're back right here. That's good to go. Let me show you the next problem in this house. Customer said that the light over the door, that was the light over the door, don't work. And I knew immediately when I pulled it down, I had all that much slack, that this is something that somebody has added later. So that should be a hot and a neutral wire. But again, when I read this, I wasn't getting 120 volts. Now, I used my voltage indicator to check it before I stuck my big fingers in there, because if I hadn't, I'd have got nailed, because someone had run this to it as well, and the homeowner took that down. I don't know what kind of a mess they had here, but at any rate, this was hot, fed over from here. Well, I was indicating voltage, but again, only 80 volts. And so basically it tells me, hey, they've broken the ungrounded here too, because in this wall socket, they had this, okay? And this is a receptacle switch combo. It's a receptacle on one side that's hot all the time, and it's a switch that, it's a single pole switch. You've got common here. While they hook both wires to it, it's unnecessary. If you can see, the tab is unbroken. Only one wire would have been necessary. Then this terminal, notice it's brass. That is an ungrounded terminal. That terminal becomes hot when you turn the switch on. It's not hot when you turn it off. This, of course, the green, ground always. Notice this is a silver screw. That is for a grounded or neutral conductor. Notice how it's polarized with the grounded side of the receptacle there, or the grounded neutral side. The longer, larger slot is always supposed to be neutral. Well, they had this thing wired up basically in a dead short. How it didn't blow, anyway, it's weird. But I'm going to rewire this. But what I need to know here, because obviously there's a cut-in box here, and this is wiring that someone has added. Notice that there's no old premises wiring in here. This is all new wiring. This is wiring that is has been added later. So one of these has to be a feed in and one has to be a feed out. And the wiring here absolutely was not right. They had it wired in a dead short, which is why that won't work. But the question comes to you, okay, you can't tell which wire's which, can you? Well, you can, if you pay attention in class and you learn how to use an ohm meter, okay? Ohm meter, or a volt ohm meter, when we set it to either ohms, that's a little horseshoe, or the ringer, is checking continuity. And it's hard for me to do this one-handed, just bear with me. So when I touch these two together, okay, it rings. Why? Because I'm touching the black and the red wires together, and I'm making a complete circuit that lets the ringer go off. When I take them apart, okay? So how do I find out which one of these wires is that wire? Well, here's how we do it. You take those wires, of course, I have already checked that there's no power on any of this. And I tie the black and the white together, just like that. Then I come back over here. I set my meter on the windowsill. You'll be able to hear it, but you won't be able to see it. And then I check my wires. Here. I'm sorry, y'all. I can't hardly hold this and do it. So you're gonna have to bear with me. I'll check my wire here and here, black to white. Ooh, I get nothing. So I'll go up here to this black and white wire and I check it. You'll just have to listen. Ah, you hear that? So that tells me that I have continuity between that black and white wire. And I have continuity because I tied the other end of the black and white together. So when I touch my probes to it, I'm completing a circuit and allowing my ringer to go off. Now, to make absolute 1000% sure, and you always want to do that as much as you can doing electrical work. See, we got continuity. We're going to go back over here. And we are going to cut these apart. Now, as you see, they are separated, okay? We'll come back over here. Pick up our probes and we'll go to the wires that formerly were ringing, okay? And I got nothing. Why do I got nothing, class? I got nothing because I've broken the circuit on the other end. So what does this tell me? These two wires here, that's the wires that are going over there to the light fixture. So now I can properly wire my receptacle switch combo in here. I will do one other thing just to make sure that the wiring is right, because you know the last thing I want to do is tear all this apart once I put it back together, right? It's easier to check to start with than it is to make, just, you know, assume. One of the great rules in electrical work, class, I want you to ingrain this into your brain. One of the great rules of electrical work is as follows: assume nothing. Did you get that? Assume nothing. Assumptions will get you dead, okay? Along with loose ends, dead wires, and elbows. Those things will kill you in electrical work and power line work. So what am I going to do? That wire should have no power on it when I turn the breaker on. I'm going to keep the neutral and the hot separate, and I'm going to go turn on the breaker. Then I am going to check the voltage and make sure I have 120 volts hot and neutral on that wire. If I do, then I know that's definitely my 120 volt feed wire. That's definitely my wire out to my light, and then I can wire it up properly, okay? So, where's the yield voltage indicator? So we check with a yield voltage indicator. We indicate no voltage nowhere. So we go down the hallway here, behind the door. I always put them behind the door in these old houses. And we turn on our breaker to that circuit. We'll come back over here. Now this won't always be a definitive test. See what I mean? That's showing power there, showing power there. But it's also showing power here. How's that possible? Well, the reason it's possible, these things are very, very sensitive. They're a very handy tool when you're doing electrical work. But I want to tell you, don't you ever trust your life to one of these, okay? It'll tell you if voltage is present, but you can't trust it to know feeds and all that stuff. Reality is I should have no voltage here. I should have 120 volts here. Now I'm going to set this thing down because I don't want to get eat up trying to hold this phone and check the voltage. But I'm going to check the voltage with my meter, and I'm going to make sure there's 120 on that wire and nothing on that wire, and then we're good. So give me a second, okay? And as I suspected, there's 120 volts on these two wires. There's nothing on these two wires. So now we have successfully determined where our feeds are, what's coming from where, what's going to where. We shall turn our breaker off again. We'll go back And just as a precaution, we will take yield and voltage detector, and we detect nothing. So we're safe. So I'm going to wire this up. I'll bring you right back and show you how I wired this up so you'll know. All right, adios. We'll be back in a minute.